on page 33. Looking at patterns of integer exponents. So when we look at these patterns, we need to make sure we think about the base, right? So we're going to have a base of 5. So all of these right here, right? This row is, all the bases are 5, right? This following row, all the bases are 4. And the last row, all the bases are 3, which we just already worked with. Now they did this multiplication for us right here, right? So remember, this means 5 times 5 times 5 times 5. Multiplying this base of 4 times in a row. And they told us this is 625. Then 5 to the third power. So this is, right, 5 times 5 times 5. 3 5s in a row, 125. 5 squared, that is just 5 times 5, 25. Okay, to the first power, it's just 5. But remember, what in the examples that I did before, we were always thinking to ourselves, well, it's really like 1 times this. It's 1 times that. It's 1 times that. It's 1 times this. So when all of a sudden we don't have a 5 anymore, it's not 0, right? It is 1. And then as we get to the negative exponent, so you can think to yourself, right? You're dividing by 5 each time. Divide by 5. 5 divided by 5 is 1. 1 divided by 5 is 1/5. So what happens here, right, is, you are continuing that pattern. You want to continue that pattern. And so 5 to the negative 2, right, is divide by 5, divide by 5. And so then this is going to be 1/25, right? I would like you to think to yourself also, right, we could have written this as 1/5 squared. So what we can do is, right, if there's a negative exponent, we can just put it in the denominator without the negative on that exponent, and it's the same value. These are equivalent. And so there are a series of ways that you could write these negative exponents. So this is equivalent, right? And this is equivalent. So all of these could be correct answers in a problem. So now if we look at the 4, right, the base of 4, notice, right, this is, again, right, 4 times 4 times 4 times 4. So 4 4s multiplied in a row. This is 3 4s multiplied in a row. This is 2 4s multiplied in a row. This is 1 4 multiplied in a row. So remember, multiplied in a row, well, what was it being multiplied by? By 1. So now 0 4s multiplied in a row is just 1, because there was always a 1 right here in front. It's just invisible, right? And so then following this pattern, right, dividing by 4. So this is, in one direction, we're multiplying by an extra 4 every time. And if we go in this direction, we're dividing by 4 every time, right? So then as we go in this direction, we are dividing by 4. So 1/4, right? And then this would be 1 over, right? So this is 4, 1/4. So here's the 1/4. So then, right, here's the 1. This is kind of like your center area. So on this side, it's 1/5. This is 5. This side's 1/25. This side's 25. So you can also see this is a pattern, right? 1/4, 4, 16, 1/16. And we could have also written that as 1/4 squared, because those two things are also equivalent. And then finally, think to yourself, right, that same pattern, then what's going to go in here? What's going to go in this box? What's going to go in this box? So this is called a dramatic pause. I want to make sure you try to think, right? And then I will let you know. Right, so hopefully you were thinking, okay, I see this pattern now. Anything to the 0 power is 1. We're multiplying 1 times nothing else, just 1. Right? This means not multiply by 3, but divide